You know, we've all seen those videos of incredible robots in a lab, right? But the second you imagine one in your own home, you know it would just get stuck on a stray sock. Well, today we're looking at a system called π0.5, and it might just be the breakthrough that finally lets a robot thrive in the real, messy world.
So seriously, just picture it. A robot walks into your place, a place it's never seen before. There are dishes, maybe a jacket on a chair, shoes by the door, and instead of getting confused, it just figures it out. It starts tidying up. That's the dream, and that's the promise we're talking about here.
And this really gets to the heart of the problem that's held robotics back for so long. See, most robots are built for perfectly controlled spaces, for factories and labs where everything is exactly where it's supposed to be. But our lives are chaotic, they're unpredictable, and that's where robots have always failed.
So how does π0.5 even begin to solve this? Well, the first big idea is a total game changer. They decided to stop putting all the intelligence in one single brain and instead create a body that actually thinks for itself.
Okay, this is so cool. They call it decentralized intelligence. Basically, every single joint, every finger pad on this robot has its own tiny little brain, a pi node. So instead of a finger sending a signal all the way up to the main computer and waiting for instructions, it makes a micro decision right then and there. It's constantly learning and correcting instantly.
And this chart just lays it out perfectly. The old way is slow, clunky, and burns a ton of energy. It's like you having to consciously think about every single muscle movement just to pick up a glass of water. π0.5's way is more like a reflex. It's instant, it's efficient, and it just works, just like our own bodies. And here's the proof in the pudding. This system, this reflexive body, boosted the robot's grip accuracy by a massive 30%. That's a huge deal. That's the difference between fumbling with a pillow and just picking it up cleanly on the first try. And it's not just about being more accurate, it's about being smarter with its power. A 25% drop in power use is enormous. It means the robot can actually wander around your house and get stuff done for way longer without constantly running back to its charger. It's what makes it truly useful.
All right, so a body with reflexes is one thing, but the robot still needs a high-level brain to make plans and understand the world. And this is where things get really interesting, because the way π0.5 learns is, well, it's the opposite of what you'd expect. So this main brain is what's called a Vision Language Action Model, or VLA. You can basically think of it as the part that connects the dots. It sees the world, it understands what you ask it to do, and then it figures out the steps to make it happen. It's the robot's common sense.
Now, get ready for this, because this slide is probably the wildest part of this whole story. Look at that chart. A whopping 97.6% of the data that trained this robot did not come from this robot. It came from the internet, from other completely different robots, from all over. To teach it how to be a generalist, they gave it this incredibly diverse data diet.
So you've got these two pieces, right? The fast, reflexive body and the smart planning brain. The real genius here is how they put them together into one seamless, elegant system.
And this quote from the researchers just nails it. Think about it. When you hold a cup of coffee, you're not consciously thinking, okay, tighten this finger, loosen that one. Your reflexes, your spinal cord just handle it. That frees up your brain to think about your day. That's exactly how π0.5 is designed to work.
And it all happens incredibly fast. Every single second, the main brain thinks a thought like, okay, pick up that pillow, translates that into motor commands, and sends a sequence of 50 smooth movements down to the body. And while all that's happening, the body's own reflexes are handling all the tiny, real-time adjustments. It's brilliant.
So the theory sounds amazing. The design is elegant. But does it actually work in the real world? It's time to find out. Let's see what happened when they took π0.5 out of the lab and put it into the ultimate test, a home it had never ever seen before.
Now just look at these numbers. This is incredible. When it moved from homes that were kind of like its training data to totally new homes, it maintained 94% of its performance. That's the key. It proves the robot wasn't just memorizing tasks, it was truly understanding and generalizing to new situations. And this table really shows us why that weird data diet is so important. It's like a recipe. You take out the data from other robots, performance drops. You take out the web data, suddenly it can't handle new objects it's never seen before. Every single one of those ingredients is absolutely essential for it to be so adaptable. And let's be super clear. This isn't just a tiny little update. When you compare π0.5 to the model that came before it, the jump in performance is huge. This whole new philosophy, this new design is really, really working.
So what's the big picture here? What does this all mean? Well, π0.5 isn't just another cool robot. It feels more like a new blueprint, a new way of thinking about how to build robots that can finally leave the lab and join us in the real world.
These are really the big lessons. We've learned that you need to separate instinct from planning, just like in nature. We've learned that a robot's training has to be incredibly diverse. And when you combine those two things, you finally get a system that isn't afraid of a little mess. In fact, it's designed to thrive in it.
And that really is the question that leaves you thinking, isn't it? This is just version 0.5. This is still early days. They've built the foundation for a robot that can truly learn and adapt on its own. It makes you wonder, what on earth is π1.0 going to be capable of?